Hi. I'm sure a lot of you have heard about the new interesting direction that Micron has gone in. They've decided to no longer um, give RAM to consumers or focus on selling RAM to consumers, but decided instead to focus on selling RAM to enterprise. And I'm pretty sure a lot of you who may not be technical are a little confused, like, why is RAM being more expensive? Why are they taking all this RAM and then selling it to AI companies instead of consumers? I thought what you needed for AI training was a GPU, not RAM, which is completely fair. That's a fair assumption because you keep hearing about all these companies ramping up and they're like, hey, we're building more infrastructure, we're using GPUs, we're using all of these thousands and thousands or millions and billions of dollars worth of GPUs for AI training. So you're like, okay, I have no idea why they need so much RAM. And hopefully, during this video, I'll explain a couple of those concepts. Number one, I'll explain what RAM is. And number two, I'll explain why they need so much of it. And number three, it may not be that wonderful to think about, but hopefully it'll make some sense. So let's start off with RAM, okay? Hopefully you can see this. I will move out of the way so you can see it in a minute. RAM, okay? RAM stands for random access memory. For those who are not technical, random access memory means that you have a certain type of memory on your system, or you can think of it like this. If we were to think of the computer CPU or the central processing unit or the compute processing unit, depending on who you ask, if you ask them, that would be like the brain of the computer, whereas the power system itself or the power supply would be the heart, and RAM would sort of be like short-term memories, like the things that you store on a day-to-day basis. But random access memory is basically this chip or this particular type of chip that allows you to store temporary memory in something called a register, which you can just think of it like this. We have this whole RAM stick, but think of it like divided up into a bunch of different blocks, right? Inside those blocks, there are things like numbers, right? So think of them being like numbers, but in a more specific sense, maybe think of it as being like a 1 or a 0. So we could have like 1 0 1 1 0 1, and that would be like a number that is existing in these blocks, right? Now, that doesn't seem too complicated, but we're going to keep it at this very high level for now, just so you know that this is basically what it is. It's some temporary storage that is held by the system. It's being held by the system. Now, we have this thing divided into two different things. We have what is RAM, and that RAM may be physical, like your actual RAM chip. So you might see like, hey, you're building a new PC and you see something there's like, oh, I see a 1 GB RAM stick, or 2 GB, maybe 4, 16, 32, 64, 128 GB RAM sticks, and you're like, yeah, I'm gonna put that in my computer because I need to game fast. But if you're a person who maybe does some stuff with the arts, you may have noticed that sometimes you need more RAM. Like I think typically on a system, where this would be like right here, 8 GB, is for some video processing, video editing software, right? So there's a part of physical memory that chip exists in, and that is its physical capacity, right? So that's its physical capacity. And that physical capacity is just how much stuff you can store inside of this temporary storage, right? And let's keep it at a very low level. Let's keep it at 1 GB. And that's the total maximum amount of things that you can fill this physical storage with, right? That's the physical capacity. But that is not how fast you can actually transfer data to your system. That is part of something you may have seen that says DDR, and then you'll see a number behind the DDR, like DDR3, DDR4, or DDR5, and maybe even more modernly, DDR6 memory. And you're like, okay, what does that mean? Okay, DDR stands for double, oh, not B, not bubble, but it stands for double, D-U-B-L-E, data rate, which just means that it's twice the amount or the transfer rate is twice the amount of the clock speed. So if we have a clock speed that is somewhere like, I don't know, like 800, let's say 800 is the hertz or the clock speed of that particular RAM chip, the actual mega transfers per second would be around 1600 mega transfers per second, right? And that is what double data rate means. Now, these older chips, the older the RAM is, the higher the voltage, right? Higher voltage. And normally lower speed, right? Lower speed. Now, the DDR generation, whether it's 2, 1, 4, 5, 6, just tells you how modern that actual chipset or that actual modern RAM set is. So normally the like mega transfers per second increases with the generation, but also the voltage goes down as well. So it's a little bit more efficient as well, because when it takes less voltage, it doesn't heat up as fast, which means that it can process things more efficiently, and is a little bit of an inverse property. But let's keep going. That is what the DDR and RAM stands for. Okay, so additional to that, I know that I wrote RAM physical. Now, when it comes to RAM, most of your applications are held between two different types of your like physical memory, right? So you have things that are pages, which these pages can be divided between physical pages and virtual pages. Virtual pages. Now, these two different types of pages are basically little blocks, little chunks of memory. So we could think of them as a little chunk of memory, something like 4 kilobytes, and then divide it over that entire physical capacity. And we have system pages where we hold in our like applications or whatever system calls we're talking about. So in this way, we can think of this, we can divide our RAM in the virtual space, in the RAM that is virtual. We can divide that between one, the kernel space, kernel, and also we can divide the other half into user space, right? This is the memory that is allocated to the actual system kernel. This is allocated specifically to the operation of the system, and the other space is allocated for applications that run on top of a system. And then there's a mapping between this virtual memory and this physical memory. There is a mapping between it, right? And these are just a bunch of addresses. So we have basically like virtual memory that may have some address, right? So X, let's go 1, 2, 3, 4 for virtual, and it maps to some location or some physical address in the physical RAM as a page with some other 3, 5, 6, 7, whatever, and some physical mapping between the virtual memory and the physical memory. So what does this have to do with Micron's change instead of Micron's change from selling to consumers to selling to enterprise? So if you're confused about why they need more RAM in not GPUs or TPUs, we must talk about the different ways that these two things work, right? We can think of a GPU as a graphics processing unit, and it's very good at matrix multiplication, which is part of how a lot of the large language models handle requests and process those requests is matrix multiplication, right? So a large language model, when it is using something like a neural network, will load all this stuff into a GPU's, like, its memory, which is a different type of RAM, which is like VRAM, which is video RAM, and it's really good for matrix multiplication across a bunch of different frames. So if you're playing a video game, you have to do matrix multiplication to go from frame to frame, and it's very good at that, right? So when you're training a different application, you're going to load the actual model and the weights and things into your GPU when you're training, right? However, the intermediary process between taking this information and temporarily storing this information before sending it to the GPU, which you have a bunch of drivers, the drivers will direct its RAM to its GPU. But in the meantime, as you're doing those calculations in that computation, it needs to be temporarily stored in the system RAM before it is then transferred into the GPU's RAM, or the GPU's RAM. So it takes some process where the driver then directs the RAM to then send it to the GPU to do the processing. So certain applications need to be loaded up into RAM, which are outside of the kernel space, loaded into the user space to be processed, to process your incoming and outgoing calls, and then sending the some level of rudimentary calculations on RAM, and then sending the rest of it to be processed by the GPU. So that means if you're doing a request, for example, let's do an example like you do a call to ChatGPT, okay? So we're on the ChatGPT application, right? And on this application, we're a user, right? So let's give us a little happy face, because why not? We're happy. We go talk to ChatGPT. ChatGPT, and you put in your request, like how much does a polar bear weigh, right? And that request is then transferred into things like bytes, right? It turns this request, this text, into bytes. And these bytes may be just different sections of memory, which are 8 segmented sections of like binary data. And it could then use this information and then turn it into a bunch of tokens, right? And those tokens themselves are just embeddings, or basically little numbers that represent the words. And then these tokens are then sent to the GPU. The GPU then processes these tokens and processes the output and then sends it back into the RAM. And then the RAM then sends it back to the user, right? So then the user gets a response in real time, or in some segmented, chunked out section of RAM, and they get a response. It's like, how much does the polar bear weigh? Well, enough to break the ice. Now that's a corny joke. I know that. I know it's a corny joke, but it makes sense in the context of being silly, I suppose. But the entire thing is, since these systems require a lot of things to be temporarily stored, and these large systems, especially these systems that are sharing requests and allocating a certain amount per application, per request, and then processing it efficiently, you need RAM to do that. Now, you're like, okay, I get that. But why focus on, selling RAM to enterprise and not customers? Well, let's be honest. How often do you build a PC? Right? Let's say, for example, unless you're someone like Linus Tech Tips, you're not going to be building a PC all the time. You don't need RAM all the time. right? So let's say, for example, you build your own personal system, and your system maybe takes up about, I don't know, maybe let's go on the higher end. Let's say you put 32 gigabytes of RAM storage of DDR. Let's do DDR4 or 5, right? DDR4 or 5, right? Cool. Now, sometimes, depending on the efficiency of your system, you might want to do a parallel system where you have multiple RAM sticks, or maybe you want to go on the higher end and you want to go all the way up to 128, or maybe like 1 terabyte, or however much you have available to your system. But in general, you're not going to be buying that much RAM. Maybe you build a PC, you future-proof that PC, and you buy that PC, and you can maybe expect for a 5 to 10 year window for that PC. Maybe you're going to be using it longer, but on average, most of your components are going to last about that amount of time. And you'll build that PC for the next 5 years, and you're probably not going to buy RAM again unless you buy another computer or you build another computer. Right, so your profit margins for that one PC, you probably buy, I don't know, maybe at maximum, if you're doing like, I don't know, like several RAM, you could do a single stick of RAM, and if that's like $58 or something like that, cool. The company makes $58 for 5 years. But if you're a company that's an AI company who's trying to build infrastructure, and you're buying not just one thing of RAM, but like a truckload of RAM, you're probably going to be like, yeah, that seems like the more viable option. Now, I think this is a little bit different. I don't think that it's a good plan in the long term to abandon your customer base, especially if the AI boom does not work out for infrastructure for whatever reason. But in the interim, it seems like it makes sense for the company Micron. Is because you're not going to have customers buying a bunch of RAM all the time. However, I do have a slight rebuttal to that as well. I think that focusing on ramping down production for customers makes it lose a lot of customers. Now, there's a lot of consumer products that use RAM, obviously. But if you're like buying all the RAM, you're like, hey, as a company, I'm not going to be beholden to my customer base. I'm just going to behold to the people that make me the most money. Then you're essentially saying, hey, we're going to abandon the customers. And the customers are normally the ones that are going to be using PCs. They're normally the ones that are going to be using consoles and other devices that require you to use RAM. But if you keep skyrocketing the price of RAM, the components themselves, the RAM goes more expensive, which means that the other things like your, computers, your consoles, your handhelds, and things like that, the price of those things go up as well because RAM gets more expensive. Now, if you buy by the truckload, maybe an industry, they're like, hey, then if you don't want to do this, buy my product instead of building it yourself, which some people may make sense. Other people may not make so much sense. But there's also other options other than Crucial for RAM. You have Kingston, G-Skill, you have a bunch of other RAM. Let's see. What is that? Corsair for RAM as well. Now, you have a bunch of different options for RAM. I think it's a little bit more limited when it comes to GPUs. So, like, if you're doing AI training and stuff like that, most of the training has been done traditionally on NVIDIA GPUs. However, there's been a slight change in the space where Google is developing TPUs that are pretty efficient at training large language models and doing matrix multiplication specifically. And also you have products that are like Arc on Intel, and you also have other GPUs like for AMD, like Radeon GPUs that are also available as well, that are slowly making their own process and being able to handle better the training for large language models and things. Now, hopefully that explained what RAM is, why it's important, and should you worry about it? I don't know. Maybe not. I know that the price of RAM is going more and more expensive. It's starting to get ludicrous and ridiculous. And that's just kind of the industry sometimes. They put a lot of things at a high price because they're like, oh, the people that can afford this are the people that we're going to be selling it to. It's the same reason that, actually, I'm not going to say that. But the point is, that's why Micron has pivoted to selling to enterprise instead of your consumer base. There are still other options, and it's not fair that the price of RAM is going up because of that. It's not the first time that's happened either, right? Whenever the AI boom started first happening, the price of GPUs also went up, right? RAM went up, GPU price went up. So it made it even harder for consumers to build custom PCs if they wanted to. However, you have more options. And any time that a business pivots, it leaves availability to other places and other companies to come in and take up that customer base. And hopefully the other companies that also sell RAM are not going to do what Micron did with Crucial. I'm not saying that it was a good or bad idea or a good or bad investment. I'm just saying that as a consumer, I prefer to be treated well by the companies that I'm purchasing things from. And if they don't treat me well, I'm not going to buy things from them, which they're probably counting on in the case of Micron. Regardless, hopefully it explained what RAM is, why it's important, why they pivoted, and just helped you learn something. Well, that will be the end of this video. Thank you for coming to my TED Talk.